Hello student, welcome and very good morning to you. Today I will be discussing the DPP on deducing relation among physical quantities, that is DPP 4. This video will be extremely helpful for those students who are preparing for NEET, main, advanced, W joint and other state joints. Please like, share and comment on the video because this comment will be extremely helpful for me to make the next video. Okay, now let's start. Question number 1. It is known that the time of revolution t of a satellite around the earth depends on the universal gravitational constant capital G, mass of the earth m and radius of the circular orbit r. Express the relation t using the dimensional analysis. So look at this. You can be established this relation t equals to, this is the some constant k, this is the g to the power a, this is the m to the power b, and this is the r to the power c. But this is the most lengthy process. Now take these options. Look at this. Here root over r cube, and this is the gm. Gm means g r square, because you know g equal to, this is the gm by r square. So gm equal to g r square. So look at this. This is the root of r by g. Look at this here. Dimension of r, this is the l, and dimension of g lt minus 2. So look at this. This is the dimension of t square. So this is the t. This represents time, that is the period. Okay. So option 1 is correct. Look at this question number 2. Energy E, velocity V, force F be taken as a fundamental quantity, then what are the dimensions of mass? Okay. Now look at this. Here energy, this is the m l squared t minus 2. Velocity square, this is the l squared t minus 2. This cancel out. So this is the m. Therefore option 1 is correct. Okay. Now question number 3. A system has a system has basic dimensions as density, velocity, and area. Dimensional representation of force in this system. So force can be written as, this is the d to the power a, v to the power b, and this is the a to the power c. Now write the dimension. D has dimension m l minus 3 to the power a. Velocity has dimension lt minus 1 to the power b. And this is the area has dimension s l square to the power c. So look at this here, m to the power a, no problem. L to the power, this is the minus 3a plus b plus 2c, and t to the power minus b, no problem. This equal to, this is the dimension of force m l t minus 2. Okay. Look at this here, power of m is equal to power of m. So here a equal to 1. Power of t is equal to power of t. So look at this here, b equal to minus b equal to minus 2. Okay. So look at this here, b equal to 2. Now a1 and b2. Look at this, a1 b2. A1 b2, only this option correct. Okay. Now question number 4. Position x of a particle depends on acceleration a and time t. Find the relation. Now look at this relation. Acceleration a, this is the lt minus 2 into t cube. So look at this. This is the lt. So this is not correct. Now look at this relation. This cannot happen because here L square. Now look at this. This is t to the power minus 2. No, this is not possible. Now look at this. This is the A. A means LT minus 2 into t square. So look at this. This is the L. So option 4 is correct. Okay. Now question number 5. The time period of oscillating water bubble depends on pressure, density and energy. Derive the formula. Look at this. So T can be written as K. This is the P to the power A. This is the D to the power B. And this is the E to the power C. This is equation number 1. Now write the dimension. This is the M naught, N naught. No problem. And this is the, look at this, dimension of pressure, that is M L minus 1, T minus 2 to the power A. Dimension of density, this is the M L minus 3 to the power B. And dimension of energy, M L square T minus 2 to the power C. Okay. Now look at this here, dimension of M. Here power A, here power B, and here power C. So this is the M plus B plus. So this is the A plus B plus C. L, here power of L, here power of L, this is the minus. Here power of L, this is the minus 3B. Here power of L plus 2C. Look at this, here power of T minus 2A, here power of T minus 2C. Now applying the principle of dimensional homogeneity. So look at this, here power of M is equal to power of M, therefore A plus B plus C equal to 0. Power of L, look at this, here minus A minus 3B plus 2C equal to also 0, and minus 2A minus 2C equal to 1. So look at this, A plus C equal to minus half. If A plus C minus half, you can write, look at this, B plus A plus C. So this is the B plus minus half equal to 0. So B equal to half. Look at this, which options B half? Look at this, option 2 and 3 is the B half. Now look at this from this relation. Look at this here, minus A plus 2C minus 3B, 3 into half equal to 0. So look at this, minus A minus plus 2C, this equal to 3 by 2. Okay. So you can write, look at this is the minus A minus C plus 3C equal to, this is the 3 by 2. Now minus A minus C is equal to half. Look at this, minus A minus C equal to half. So half plus 3C equal to 3 by 2. So look at this, 3C equal to 3 by 2 minus half equal to 1. So C equal to 1/3. Look at this, C equal to 1/3 and B equal to half. Only this option correct. So option C is correct. Okay. Now question number 6. If a force F, velocity V, time T are taken as fundamental quantities, find the dimensions of energy. Okay. Look at this. You know the dimension of velocity into time. This is the LT minus 1 into T. So this is the L. Now force into displacement, that is force into length, is the energy. So F into L, that is F into V into T, is the dimension of energy. Look at this, option 3 is correct. Many thanks for watching this video. To boost your preparation for NEET, main, advanced and W joint, subscribe my channel. Okay, thank you.